All right. This example, we're going to combine all four transformations in one question. We're going to transform y is equal to x squared into the graph y is equal to negative 2, open brackets, x minus 1, close brackets, squared plus 4. First thing we should do is we should graph y is equal to x squared. And what did you know it? There it is. Construct each transform graph in a different color. Also note the transformation in words and the functional notation. So here, I'm just going to pick out a. The coefficient a, the value of it was negative 2. H was 1. K is equal to 4. So I was able to see A, H, and K. So since A is negative 2, we have to reflect it, and we have to stretch it by a factor of 2. Since H was negative 1, we're going to shift 1 unit right. Since K is 4, we're going to shift 4 units up. So I'm going to start each question simply by starting off with xy, and I'm going to change point xy, which is on y is equal to x squared, if I reflect it. If I reflect point xy, it turns into x comma negative y. I do find point notation really helpful when I'm transforming functions. So every point that is on my previous example, I reflect the x-axis. I missed that one, didn't I? And point xy maps into point x comma negative y. Now when I stretch my graph, so I'm done with reflection. Let's go on to stretch by a factor of 2. I know that every point x comma negative y now turns into x comma negative 2y. That is, I stretch my graph by a factor of 2, and what we're doing is we're multiplying our y values by 2. On the graph, they look like this. If you notice, those 2 points got stretched beyond my axis, so I'm only going to carry 3 points along with me. H is equal to 1. We're going to shift all the points 1 unit right. So the point at negative 1, negative 2 will move to 0, negative 2. Point at the origin, 0, 0, moves to 1, 0. The point at 1, negative 2 moves over to 2, negative 2. So this parabola, okay, that was a poor parabola, but just bear with me, I'm trying to do my best. This parabola now has the same shape, but just moved over. Last but not least, 4 units up. Oh, sorry, I forgot my point notation there. If I'm shifting 1 unit to the right, it turns into x plus 1, negative 2y. Now, if I'm shifting all the points up, so I'm working off the green graph, sorry, I'm going to start off with this point 0, negative 2. I'm going to move it 2 up, sorry, 4 up. My mistake, 4 up. It moves here. 1, 2, 3, 4. It moves to 0, 2. This point here at 1, 0 moves up to point 1, 4. Point at 2, negative 2 moves up to 2, 2. So I have my 3 points on my transform graph. Make sure I have arrows at the end of all of my parabola, and everything's all good. So I moved my points x plus 1, so the x value stayed the same as the previous transformation, but now I simply add 4 to the y values. One may ask, what order of transformations must we do? And really, there are multiple ways of doing it, but I would really strongly suggest following the order of operations. It's a great theme. And you may be asking me, order of operations with graphs? Yes, if you look at the description of all the transformations, reflection, reflection and stretch. That had to deal with the coefficient A. We multiplied the y values for anything to do with A. H and K, we added to the x or y values depending on the transformation. So really and truly, we have to take care of all the multiplicative operations of reflection and vertical stretch, and then we can worry about the additive of horizontal shift and vertical shift. A lot of people point out to me that can't you just follow it in the order that it appears? And indeed, you can. It's just a nice coincidence. Good luck with transformations.